welcome. Can you all see my screen? Yep, good. So I'm Solomon Bawa, and with me is Lauren Lee, where we anchoring this session, this tester lecture on revolutionizing material synthesis, how robots and AI drive the digital manufacturing of advanced material. Both of us are lecturers in the MSc program, Digital Manufacturing of Advanced Material. And this is a program that sits within the Department of Chemical Engineering, University College London. And this MSc program is within the Manufacturing Futures Lab entity, which incorporates 6 others MSc program. And within this Manufacturing Futures Lab is a kind of interdisciplinary space where researchers across different disciplines interact with each other, both on research and teaching purposes. And within this Manufacturing Futures Lab, which is within our UCL East new campus, which is within the Queen Elizabeth Olympic Park, we have exciting facilities and lab space for both research and teaching purposes. And our students have the luxury of interacting with state-of-the-art facility. As we can see from this picture, this is a picture of different sections of the Manufacturing Features Lab, which also our students in our MSc programs we have interaction with. And the program was carefully designed with our industrial partners, and this was useful to know the skills that is needed for the next generation. And with this in mind, our students, after graduating, will have a very high skills that is in demand across different sectors, the pharmaceutical sector, the healthcare sector, energy sector, because they will be equipped with knowledge across robotics, automation, AI, machine learning. And this program was carefully designed, and it cut across different modules which are being taught in term 1 and in term 2. In term 1, students have the experience of getting to know what materials are, how to synthesize material, as well as characterization. Aside that, they also learn computational tools, and also they are exposed to data science, where they know most about machine learning, AI, and also apply application of digital material manufacturing. Also in term 2, students have the opportunity to implement the theories they have learned in term 1 into hands-on experience in the lab. Like for one, I handle data-driven materials manufacturing, which is an integrated module where students engage with robotics. They apply their coding skills into practice to control the robot. And also they are being exposed to automation of materials manufacturing. These are the core modules. But aside the core modules, students also have the opportunity to take optional modules which are available from other MSc programs. This is to increase the horizon of their knowledge to pick optional modules. But it's worth noting that these optional modules do change. And in term 3, our students have opportunity of picking research project, engaging with cutting-edge researches, which will be closely supervised by the academics within the program. And our teaching spaces are very nice, very interactive. And as I said earlier on, our students always have opportunity to have hands-on experience to implement the theories which they have learned in the class within the lab setting. And our lab are well equipped with the state-of-the-art facility, which gives them the luxury and the atmosphere to implement what they have learned in the class. Most of our classes, our lectures are face-to-face and very engaging sessions. And this program welcomes students from different disciplines, different backgrounds, that are all engineering background, sciences, material sciences. These are people that are welcome to apply for this program. So it's a multidisciplinary space where people come to learn both, they are equipped both experimentally and computationally. At the end of the program, our students are strong in both directions. Most of the times in some program, students are either heavily experimental or heavily computational, but within the digital manufacture of advanced material, students will have strength in both directions. And these are skills that is being required out there. So this is the kind of brief structure of the program, and it's been delivered by amazing staff which are well experienced in diverse fields, as you can see from this slide, and they come across different continents and they give the student nice experience. So this is a kind of this is just a brief of what the program is, what we deliver, and the expectation for the MSc program of digital manufacturing of advanced material. Now I'll hand it back to Laura to continue with the tester lecture. Laura, over to you.
Okay, thank you very much. As Solomon and Max introduced me, I'm Lauren Lee. I'm a lecturer of chemical engineering at UCL. So let's deep dive into AI and how they have revolutionized the material discovery. So why advanced material? In today's world, we face increasingly complex material challenges, from designing a sustainable metal organic framework to combat climate change, to capture CO2, and to develop life-saving drugs rapidly, and create innovative materials to drive sustainable energy. And yes, materials truly are the backbone of modern life that enables positive environmental impact, societal progress, and technological advances. And the demands of advanced materials is growing rapidly, as you can see in the bar plot. And these growth reflect their critical roles in addressing some of the most pressing global challenges, including suppressing climate change. But at the same time, the vastness of chemical space poses a significant hurdle. We are talking about identifying few optimal materials out of billions of possibilities. So it is almost impossible mission if we rely just on trial and error approaches. And let me give an idea about the scale of we are dealing with. So think of constructing a molecule using these molecular function groups. As you see, CH2 or H2 groups, you can think this is our building block. You can think this as a Lego pieces. So you're creating certain amazing structure using the Lego pieces. So this individual unit can be assembled in countless configurations. And with just 20 building blocks, we end up with more than 1 trillion possibilities, as you can see. And now imagine evaluating each configuration, each materials, take just 1 second, and screening all possible combinations then it would take more than 200 years. So clearly, this is not feasible approach. So to tackle this combinatory explosion, we need optimization techniques, probably powered by AI. So this way, we save significant time, resources, and efforts while focusing on most promising solutions. And also, developing new material isn't just about design. So once you design the molecular structure, we need to make them in the lab, test their properties, and analyze their performance. So this is what the design, make, test, analysis, so-called DMTA, a cycle is all about. So it is an iterative process to develop and optimize materials. And this is why understanding broad scope of material manufacturing is so important, as supported by our DMAM master degree program. And traditionally, DMTA cycle rely heavily on manual process, as you can see on the left-hand side. So designing material was based on heuristic or based on expert knowledge, and synthesizing them in a lab manually, and testing them and analyzing manually. And this approach can take several decades to discover a single material. But in contrast, modern self-driving lab, powered by AI and robotics, it can transform this process. So for example, AI optimizer intelligently design materials, robotics automate the synthesis and test steps, and real-time computational tool can analyze the data. So this process can reduce the timeline from years to just weeks. So now we understand the importance of having systematic tools to efficiently explore the vast molecular design space. But the question here is, how can we do this faster and more efficiently? We just mentioned about AI. And this is where digital tool, computer-aided molecular design, comes into play. So by leveraging those digital tools, we can systematically navigate this enormous design space, evaluate material performance by using the computational tool, identify promising candidates, and optimize them for desired properties. Again, by predicting the property of molecules before they are even synthesized, the digital tool like can help us drastically reduce the number of experiments required, saving both time and also resources. So to understand how digital molecular design tools, how it works, let's look at its two key elements here. So first, we need a property prediction model, which map the relationship between a molecular structure and its properties. So by changing the molecular structure, you want to evaluate the performance of molecules. So the property here can be heat capacity, reactivity, synthesizability, or melting points. And these models can be mechanistic, developed using physical principles, or it can be data-driven, powered by AI to predict the property accurately. The second step is optimization. So once we calculate the property of molecule, optimization algorithm help us explore the molecular design space, of course, systematically. So the goal here is to find the best molecules that meet the desired performance criteria, and this involves an optimization problems, essentially a mathematical way of ranking most promising candidates. So in summary, what we want to do in molecular design is, again, systematically search the design space for a point X, which represent the molecules, then maximize the specific property represented by this fx objective function. So we mentioned that fx would be the property prediction model, but this raises a key question. How do we efficiently model this fx, this property prediction model? So think about heat capacity, for example. In this case, we might be able to use the mechanistic model developed based on thermodynamic principle. Now, how about activation energy for reaction? So this, as you see, involves many molecules, and you need to understand the interactions of those. In this case, maybe a mechanistic model is not may not be available, or it might need extensive computational work or experiments. But even though we obtain data, we might end up not being able to understand the underlying mechanism. And in such case, we can turn to data-driven or AI-driven models. So here then, another question you might want to ask is how many experimental data we need to obtain to build a good AI models. And AI actually can automate two critical steps in here. So first, configuring property prediction models, and second, it can also design experiments. So instead of relying solely on manual efforts, AI learns from existing data to make accurate predictions and efficiently prioritize which experiment to conduct as a next step. And indeed, in this year, we have witnessed the historic achievement in AI, marked by the Nobel Prize, actually 2 Nobel Prizes in physics and chemistry, being awarded for AI-related breakthrough. So Hinton and Hofield here, their pioneering work on neural network actually laid the foundation for modern AI. And Sabis and Jumper, who developed the AlphaFold, solved a 50-year challenges in protein folding, which is really important to develop develop medicine. So the recognition of AI at the highest level emphasizes profound impact across many scientific sectors, including shaping the future of material. So like recognizing AI's potential in material discovery, let's explore how AI and computational tools streamline the discovery process. The first step is defining the target property or problem. So here you might want to maximize heat capacity, for example. And next, we collect data. So data is important, of course. You can collect the data either experimentally or through computational simulation. And the raw data is then transformed into features, like molecular fingerprint or descriptors. These features are usually designed to capture the essential aspect of the molecular structures. And using these features, we train AI models to predict material properties and performance. Of course, employing advanced AI technique such as graph neural network. It could be a deep neural network. Also, it can use a large language model, LLM. And indeed, we use ChatGPT-like large language model to, design the molecules. And finally, the trained models are used for optimization. And it suggests new candidates with the desired properties. And this process is iterative, as we talked about, refining predictions and experiments until we find optimal solution. So now that we have discussed the data science pipeline in material discovery, let's look at real-world applications, which is about AI-driven antibiotic discovery. And this is just one of many success stories. And antimicrobial resistance, in short AMR, is a global health crisis causing over 35,000 deaths annually in the US alone. So to address this urgent issue, researchers are turning to AI to uncover novel antimicrobial compounds and mechanism of actions, because it's really hard to understand the underlying complete theory. And it's going to take so much time if you try to understand fully and then design. In this example, antimicrobial peptides were designed using AI-driven approach. The framework starts with the data acquisitions using the existing data set, which contain 3,000 peptide sequence. And machine learning model predict the key properties like antimicrobial activity and then biophysical traits. And then generative AI model, such as variation autoencoder, successfully design the entirely new peptide molecules. And also the performance of those newly designed peptide molecule were also validated experimentally against the bacterial strain like E. coli. So the whole work showcased how the AI-driven pipeline translate into impactful discovery, addressing global health challenges with precision and also with speed. So while AI demonstrated transformative potential in material discovery, it's important to ask too, are we doing good enough? The short answer is maybe not yet. So for example, so what I'm saying here is that there's still a significant work to be done. For example, many AI models are application specific, meaning they work well for a specific problem, but can't generalize to other tasks or a completely different design space. So generalizability remains a major hurdle. Also, there is issues of interpretability. We often call that like AI-driven model, data-driven model as a black box. So still, it's hard to understand what is going on inside of this black box. We want to understand the mechanism because we're dealing with physics, but it's quite hard. And most importantly, AI models are only as good as the data they are trained on. And one of the biggest challenges today is the lack of high quality, reliable labeled data in many materials and chemical applications. And often the data we have is biased, incomplete, or of poor quality, which limit the AI model accuracy. So for instance, an AI trained on familiar data might perform perfectly, with that context. By the way, the model, the data used here was very sparse and biased, although it gives an extensive, a huge data set. But when the model try to make the predictions for unseen data, as you can see, it struggles significantly. So improving data isn't just an option; it's the key to make to making AI truly transformative. And to fix this, we need to generate a large amount of accurate and diverse data, and in that, automation lab can play a significant role. So finally, integrations with robotics is crucial. To fully close the loop of the design, make, test, analysis cycle, the MTA cycle, we need seamless collaborations, orchestrations between AI models and robotic systems. So I would like to conclude with the lecture by mentioning your role as the next generation of researchers. Yes, you have an exciting opportunity to address all these challenges. AI and robotics provide amazing tools. It's your creativity, your knowledge, and innovation that will drive the breakthrough. Okay, now I'm going to hand it over to Solomon again, who is going to talk about how you can use a robotics automation facility to generate data.
Thank you, Lauren, for that amazing template of the crucial need of AI model. As stated by Lauren, the starting point for AI model is data, and not just any kind of data, but data that is of high quality. There's diversity, there is low variability in those data. And as stated, AI requires enormous lot of data. But how can you get those data within the time frame, reasonable time frame? As such, robots are very important in this sphere. As stated, you need automated platform. But this, what we can see here, has shown how robotics and automated platform have been evolving. We can see that back in 1965, you can see how an automated platform looked like. But back to 2020, you can see how robot works within a lab workstation, how robots help in the workflow of your experimental process to generate data. So this shows you how significantly this field is growing and is gaining much attention, and more attention is needed even in the future. As such, the knowledge of robotics, it's very important. The crucial application of robotics to discovery is essential. As such, our program of digital manufacturing advanced material ensure that students get these skills within the program, because it's something that is needed for material discovery in future. So this is just to highlight to see how significantly automation and robotic platform are actually evolving and actually moving on. And for a robot, these are systems that it needs to be in an operating an automated fashion, and it performs experiment with minimal presence of the user. So this platform should be reprogrammable, meaning it should function in different phases based on the task I give it to do. A certain time, it can change. This is based on what the algorithm that drives it. And it should work in an automated fashion. For example, you want to synthesize a particular compound that has different combination of different chemicals. As highlighted below, imagine you have 800 combination of chemicals. And with this, you have to consider some variables such as temperature, the time that the reaction will take. And with experiments, it's important that you repeat every condition that you are running. Because if you just work with one data point for each experimental run. It might be by accident, but when you repeat it over time and you still get within this tolerance limit, you get the same result. It shows, yes, this condition translates to that condition. And so you have 3 repeats for 3,200 data points and 3 repeats. Wow. Somebody said this is huge data to be produced. But imagine you have to carry out this process within the lab with your manual pipettes, doing the combination of different chemicals, 9,600 experimental runs required. Imagine, how long will it take you? Even if one experimental point takes like 30 minutes, can you see the enormous time, the energy that you'll be required to put in to achieve this experimental goal? With this, because it's so labor intensive, time consuming, resources consuming, and it's prone to a lot of error, which will downplay the quality of data that is needed for AI model, especially within the sphere of material discovery, then robots are the answer to phase out all these eventuality or this constraint associated to generating and developing AI models. So liquid handling robots is very essential and very important. And these can help to do all these pipetting tasks that rather when you want to do them manually, it requires a lot of time and effort. But with the liquid handling robot, it do it very fast. The error margin is very low, meaning there's good precision. And this facility, we also have it within our labs. And with this, like from the right, you can see that it's a single, there's the multi-channel, which is 8, and there's the 96. So with this, you can generate a lot of data with less than no time. With this liquid handling robot, as is being illustrated in this short video, the amount of reagent used is very small. So this shows that the waste you generate is very slow for a sustainable practice. And you can generate a lot of volume of data at a go. And it's very fast. You don't need to be there. After you program the liquid handling robot, it will carry out the task by itself, and it is safe, and you can actually pay attention to other more complex tasks because the robot has been programmed to carry out the tasks of the experimental run. And as I've highlighted before, is very precise and the error margin is very low. So this will help us to generate a lot of data with minimal effort from you, the researcher. In our teaching program, I will put our students into engaging with this robot. For example, one of the first steps is for them to undergo calibration process. As you can see, this student engaging with the robot, because calibration is very important so that the robot will be able to execute the tasks which it is meant to do. And students also learn how to synthesize material in an automated way via high throughput experimentation, which generates a lot of data. And after those material has been developed, we now analyze them, and this can be good data to develop model that can represent the process. These are part of what we teach our students within the MSc program. Also, we have the luxury of integrating custom-made hardware, so within the liquid handling robots. So you can come with clever idea, design a piece of hardware and integrate it. Like this is a smart centrifuge that was designed and integrated into the liquid handling robot. What is it? It saves time and it is faster, and the results are very reliable. Finally, we have seen the issue of precision accuracy is very important, which the robots we can leverage from the robot application, and also it increased high throughput. We generate a lot of data with minimal time, and these results are reproducible. And the reproducible nature of these results will now make us to have a reliable AI model for material discovery. More so, it reduces risks you don't interface with the chemicals you're dealing with because it's within an enclosure where the robot is. But if you are doing your manual pipetting, you may be exposed to this, maybe some of the chemicals that may be nasty. And finally, it is very, very time efficient. So with liquid handling robots, we can see that we can generate a lot of good quality data that could be used for training and developing AI model for material discovery. For our MSc program, to get to these are links that you can keep in touch with us to know more about the MSc program. The applications are on, and these links you can send in your question to the program director, which was introduced at the beginning of the session, to know more about the program and the things we do to equip the scientists and the engineers for the future in the aspect of data and also material discovery. I'll also hand it over to Laura as we wrap up the session. Laura, okay. Over to you.
Okay, thanks, Solomon. Thank you for introducing the amazing work that has been done with the automated facility and robots. So now we would like to conclude the whole presentations. So first thing, stay connected and keep an eye on the upcoming events as you see in the slides. So mark your calendar for the postgraduate open days on January 25th in 2025, and also master degree webinar on January 29th, and also UCL East open evening on February 4th. And for inquiry, like Solomon mentioned, contact us through this email, and don't forget to explore more opportunity through the provided link, as you can see here. So now the floor is open to your questions. So feel free to ask any kind of questions.
Or you can also maybe type it in the chat. You can drop your question.
Yeah.
So I've seen the ask of what kind of projects students have worked in the past in this program. So as highlighted previously, within the teaching team, we have different expertise, and students work with projects within this expertise. So we have people working machine learning models, some work experimentally in experimental work that involve acrylamide synthesis in a robotic platform. So, and also some people do on optimization. So based on the expertise of the academics within the digital manufacture of advanced material, there are different ranges of projects which students have luxury to choose from. Lauren or Max, do you want to add anything to that?
Maybe I can add one thing. So as you see, like material discovery takes several steps that involves designing, making, and testing and analyzing, steps. So the whole research going to be those research projects are structured around this each activities. So some of you are going to focus on developing an optimization algorithm, AI algorithm, to suggest new materials. And some of you are going to go to the lab and work with robots to synthesize materials. And also some of you are going to focus on how you can accelerate the test and analysis steps. And maybe some other students are going to focus on integrations of design, make, test, and analysis steps. Is there anything you want to add, Solomon?
No, that is it. Covered it.
So another question, what is the career prospect of this program will offer. I have a computer science background. Is it suitable for this program? The short answer is yes. So actually, in this year, we have many computer science, and we have many students who have a computer science background. And one thing I want to mention that actually I was in a talk that one of academics who won the Nobel Prize talked about their developments in AlphaFold. And what he emphasized in here is that we need someone who understands the system, who understands the physics, and also the computer science computational tool. So I think that this program provides a perfect combinations between computer science and engineering. So we also every year in our each lectures, we also invite people from industry. So for example, I had a guest lecturer from GSK and also AstraZeneca. So they talked about the job opportunities, and also other programs had many different industry people. So you will have your own network to the industries.
May I quickly add on to this, Lauren?
Yes, go ahead.
No, I would like to highlight that this is an interdisciplinary program. And for the reasons Lauren just described, just doing AI and machine learning is not enough to get the job done. You have to understand the data you're dealing with. And we are aware of this interdisciplinary requirement. And that is why we welcome scientists, engineers, computer scientists. Actually, this year our cohort is 30% computer scientists. So we welcome people from all these science and engineering disciplines, yeah? And we do not expect you to be good in all of these disciplines. We do not expect you to be good at material science and computer science, absolutely not. We expect you, if you join this program, to be motivated and interested, and as an opportunity to learn the field you're not good in, but you think is important, and you're really interested to make this part of your skill set. So just to clarify, if you're a material scientist, you're very welcome. We will teach you coding. If you're a computer scientist, you are very welcome. We'll teach you material scientists. And to all of you together, we will teach you things like robotic, high throughput experimentation, and advanced material synthesis. So again, everyone with a science and engineering background interested in these activities is absolutely right.
Yeah, so another question from audience: for a Masters of Science, would it be a one-year program? Maybe Max, could you quickly give an answer to that?
Quick answer is yes. It's a one-year program. There is at the moment no part-time option. Also for the reason that these modules are designed that they connect very nicely. Like you learn the basics and the fundamentals in term 1, term 2. Solomon will lead in the lab. You will work with these robots, for example, that he just showed. And then you have this master project with myself, Lauren, Payman, Solomon, Reza, our wonderful teaching academics here in this program, either more experimentally or computationally. That was a long answer for the short question. Indeed, 12 months it is.
Okay. Also, we have another questions about the program. So could you please highlight again about the requirements for the applying and registration purpose for the postgraduate?
So I'm trying to find the question, but the requirements, I think, thank you for putting up the slide. To be clear, what we cannot accommodate if you have a social science degree, because as I said, it's very interdisciplinary, and we expect students who are good in the material science, chemistry, mechanical engineering, all these allied fields, material science, physics, chemistry, incredibly welcome to learn more about coding, computer science, AI, machine learning. Those with a computer science background or allied fields, we expect to learn with us about the material science bit, yeah? If you, however, have no background in any of these fields, you might struggle, and that is usually not what we are looking for in the students. We are looking for students who have a science engineering background of any kind and who are interested and motivated to explore and extend their skill set. That's what we're looking for. We are, of course, it's always competitive. these MSc programs, but we also very much welcome people from industry. So there is a certain mark and grade threshold you have to meet for this program. However, exceptions can be made if you have industrial experience in a relevant field to this program. And since this program is rather broad, that could be material science or the digital part as well. So these are the requirements. Quite frankly, we're looking for motivated students who want to learn another discipline.
I think we have several more questions about applications, and we have someone from nanotechnology engineering. And asking about the requirements again, and maybe Solomon, you could talk a little bit more about like the optional module. Actually, we have nanotechnology engineering relevant modules. And actually,
these are the core modules, like those that have nanotechnology background, just as what the program director, Dr. Marks, have said. We are looking for those that have a science and engineering background that are motivated for this program. So if you have nanotechnology background, yeah, you're welcome to apply for the program. It's just that what we don't want is those people with management or social sciences that do not have the basics. So they will struggle a bit. But those that have maybe some of these skill sets, skewed to either the material or the computational side, our core modules are balanced to cater for the need of both the computational and the material or science-based background. So you're welcome to apply for the program. And just as we have the email of the program director, you could also ask for more clarification or even a meeting. We are open to meet with prospective students that want to apply.
Yeah. Yeah, one more question here. Are there any specific exams we are required to take? Are you talking about within the program or to get into this program? So to get into this program, I think we don't need to take any exam. But within this program, there are going to be some assessments you need to work on.
There is an English test. I think if you're not from an English-speaking country, you have to pass the threshold there. This is, I guess, very understandable because we need to make sure you can follow the lectures. That is, I think, one requirement. It's not a test at UCL, it's a certificate, IELTS certificate you have to upload. So the way it will work, the application process is you apply based on your current marks, based on of course, your application letter where you explain why this program is relevant to you. Also your CV where you might want to highlight your experience, your work experience, your research experience, your interest, your educational background. And if you would be successful, you would be sent a conditional offer. Meaning at the moment, under the condition that you meet the requirements at the end of the year, and these requirements are related to your marks, the English certificate, once you meet them, your offer will become unconditional. And that is then the fixed place in the program. That is the procedure. That's also why I would recommend to apply as early as possible to make sure you're in the system at an early stage.
Okay, more questions coming up. So again, it's about their background. So could someone who has been a software engineer for the past 6 years, but have been pursuing machine learning as self-pursuit, could be a candidate to this program? I guess, yes. Like we said before, there are many students in our current cohort who have computer science backgrounds, and they're doing really great. So we are going to teach what is material, what is chemical engineering, and because you have software skill, coding skill, maybe for you it's going to be much more easy to write down the code, apply the AI algorithm for the actual physical system. Like I said before, having these combinations, like engineering background and also the computer science or software engineer, would be amazing, I guess.
And just to add, the skills you are going to learn is about the material synthesis and the robotics also, because as highlighted in the talk, it's not just good enough to just use data, but when you understand the source of the data, meaning you understand the system, then it gives you an edge to troubleshoot when you have some problem. Usually algorithms are going to return results, but does that result make sense? It boils down to, do you understand the system? So within the program, you will not understand how you source data, how data are coming from, especially related to material synthesis, and it will not give you an edge that you don't just work with data, but you understand how data, where data is coming from, and again, you can tell what downplay the quality of data. So that's additional things that you will learn within the program.
Yeah. And also, let's talk about the robots. So it seems that it can automate everything, but actually, we are the one who need to operate robots. So the robot itself needs a code, a specific software to deal with. So you see, like the role of a software engineer or data scientist in this program. And so you're going to broaden your knowledge toward the actual engineering system. In our case, material discovery or material synthesis. So the next question is about funding. Could you maybe give any comments on that?
So we will post now the link to the chemical department, the departmental website, where there are some opportunities for funding. There is usually academic excellence scholarship, financial hardship scholarship, which we would rework. There are other opportunities as well, but I think the best thing is if you have a look at our departmental website. We will put in the link here in a minute. And there you find more about these things.
And the link for the funding has been loaded in the chat, so you can follow that link for more information about the funding, just as Max has stated.
Yeah. Another question is about the English requirements, like IELTS, and what is the score, a minimum score we need to have. I guess that is also provided in the UCL website.
Yeah.
So maybe we can provide a link here, if there is. Yeah. So it really depends on your nationality as well. So if you're from an English-speaking country like Canada or state from the United States, your English requirements might be exempted. So please have a look. So Beck's gonna share the relevant link.
Yes, I'm sharing this just now.
Mm-hmm.
So this is the link to our prospectus page. So that contains all the relevant information, how to apply, also the requirements. Many things we discussed today are summarized there. Also a few links there to the actual facilities. That is, and all these questions are addressed in writing and a bit more precise than what I just said. But indeed, you have to pass this English test. I'm not ad hoc. I don't know to what level, but that is on the prospectus side, which I'm screening now. Yes, level 1. So as the prospectus page tells you, it's the English level for this program is level 1. So that would be what you would have to prove to have.
Okay. Any final questions? I don't see any new questions at the moment.
Maybe
Just
to add
to
on,
encourage these participants, in case any question comes up after the session, you feel free to reach out to the program director. Already the email is in the chat for further questions that may erupt or any clarity that you may need. Maybe you might, after going through the prospectus and some question may crop in, please feel free. We are accessible and willing to support and help as much as we can to give you the information that is needed.
Okay, we have one more question actually. Someone is asking about, again, it's his or her background. It is about yes, saying I have a mechanical engineering background with mechatronics options, and then can I apply? So the short answer is yes. And I myself have a mechanical engineering degree for my undergrad, and now I'm here. So definitely, you see, it's possible, and you can apply. And one more question here. What was the question?
Yeah, I'm looking myself if we had this question. Or could you ask this question again, just in case we cannot find it at the moment?
Yeah, try to ask questions using this Q&A box. It's easy to follow.
I'm looking for it at the moment.
Yeah.
But yeah, just to confirm with the other one, we do have currently students with a mechanical engineering background. So I would say you fit certainly just in.
Yeah, somehow I cannot find the...
There is a question about from if and how you do require an IE LTS. I do not know this exactly. It depends on the country. I would think the best thing is if you could reach out to me via email or reach out to that email that is shown on the slide here. That is the PG -cameng@ucl.ac.uk. So by all means, probably the best way is if you reach out to the departmental address, the PG-cameng@ucl.ac.uk, and put me in CC and ask the question specifically for your country and your nationality if you are obliged to also do the IELTS exam. I understand it might depend also where you did study before. If you have done this before, what counts as this? I do not know the details about this, but if you reach out to these email addresses, we will find out for you.
Yeah, and there's one more question about scholarships, and we share the link about the scholarship. So if you go to the website, through the link we shared, you can see the list of the scholarship you can apply for.
There is also one question about courses of other departments. So there is an option for optional modules. So on the program page, you saw it rather briefly, optional modules are there, which you take in term 1 or 2, and they are from different departments, also chemical engineering, but also mechanical engineering, and even departments that are not within basic engineering. So within this program specifically, you are obliged to choose one optional that is technical, that has options, for example, from mechanical engineering. And you're also obliged to choose one where you can pick from something that is less technical. That could be about entrepreneurship, that could be about find your future as well, where you're trying to get an internship. That is what we call the UCL East Suite. So where there's a mixture of modules, not only from an engineering and science background, but also the social sciences, the management, etc., provide courses there that you can pick. So I'm quickly looking if I find a link to the UCL Institute, but if again, if you go to the prospectus page, which is the link I put in before, it's what is called list B there. So you have the list A and list B, and you have to choose an optional on both lists, meaning one each. And the list B, as you can see, is the one with rather diverse portfolio as well.
Yeah, any final question? Any last minute question? Yeah, I don't think we see any new questions. Okay, then I guess we can wrap up the session. Yeah, so thank you for the hosting this session, and I hope we gave a broad insights about our program and what you're going to learn, including AI and robotics. Solomon, do you want to make like a last?
So it was great
Yeah.
having you in this session. Hope you find it useful, and please feel free to reach out to the email address we have stated earlier on for any further question. Mark?
Yeah, thank you all for joining and for all your engaging questions. We'll be in touch with the recording, and as mentioned, if you do have any questions, please do direct them to Max or our department T&L team. Yeah, have a great day, and thanks again for joining. Bye, everyone.
Bye, everyone.
Bye.